Good morning, everybody. Welcome to my channel, Proper Guidance. Today we will learn about pseudocode. This is from chapter number 4, and this is our class number, part number 4. Okay, for class 11. So, previously we have already learned about algorithm and flowchart in the chapter number 4. And now the continuation is for the chapter, and here we are to read about pseudocode. Now see, first we will give the definition of a pseudocode. What is pseudocode? A pseudocode is another way of representing an algorithm. We all know what is an algorithm. Okay, this is already discussed in previous classes. Uh, if you want to go through all those previous classes, please go through. It will be helpful. And now, uh, let's continue the chapter. It is considered as a non-formal language that helps programmers to write algorithm. Okay, it is a detailed description of instructions that a computer must follow in a particular order. It is intended for human reading. So it is considered as a non-formal language, right? Now the word pseudo means, what is the meaning of pseudo? The word pseudo means not real. So pseudocode means not real code. This is the meaning of pseudocode. Following are some of the frequently used keywords while writing pseudocode. These are input, compute, print, increment, decrement, if else, while, true or false. These are the frequently used keywords while writing pseudocode. Now see, write an example or write an algorithm to display the sum of two numbers entered by user using both pseudocode and flowchart. This is the vital part. You have to use both pseudocode and flowchart. Now see, pseudocode for the sum of two numbers will be input num1. First you have to give the input of number 1, and like this you can write it. Input num1, then input num2, compute result equals to num1 plus num2, and then print result. This is the pseudocode for the sum of two numbers. But the flowchart for this algorithm is given like this. We have already discussed flowchart in the previous part of the chapter number 4. Please go through the details right there. For flowchart, you have to draw like this. First the start button, then read num1 num2, then result equals to num plus num2, then print result and stop. Flowchart to display sum of two numbers. Please go through it. This is very easy part. I think there is no problem. And here is another example. Write an algorithm to calculate area and perimeter of a rectangle using both pseudocode and flowchart. This is the second example. Both, you have to write down both. Now, to calculate area or perimeter of a rectangle, we know the formula. For area, this is length into breadth, and for this, you have to first take input length and input breadth, then compute area, print area, compute perim equals to this one. And there is two compute section, one for area and another for perimeter. For perimeter we have taken perim as the name, and there print this one. So this is the completed part of pseudocode. We have to write down pseudocode like this one, and then the flowchart as usual. First you have to starting from here, start button, then input length and breadth, then area. We have to compute here length into breadth, print area, then this, then this and that. Okay, I hope you can understand all this clearly. If there is any problem, please ask me in comment section. I will definitely clear the factor. Now, what are the benefits of pseudocode? This is not exact programming, right? But here are some benefit. Why we use pseudocodes? Now, before writing codes in a high-level language, a pseudocode of a program helps in representing the basic functionality of the intended program. This is the main purpose of pseudocode, right? Pseudocode is nothing. It is not a high-level language, but Before writing codes in a high level language, a pseudocode of a program helps in representing the basic functionality of the intended program. By writing the code first in a human readable language, the programmer safeguards against leaving out any important step. Besides, for non programmers, actual programs are difficult to read and understand, right? If you have no knowledge of computer language, then it is very cumbersome to understand all the programming code, right? But if pseudocode is used, then it helps them to review the steps to confirm that the proposed implementation is going to achieve the desired output. This is the main purpose of using pseudocode, and this is also, we can call it, the benefit of pseudocode. Okay, so this section is completed, pseudocode. And now the most important part, flow of control. This is very important for problem solving chapter, to solve any problem with the help of any computer language. This is very important factor, flow of control. What will be the flow of your programming language? Okay, so the flow of control depicts the flow of events as represented in the flowchart. According to the flowchart, you have to control depicts the flow of events. The events can flow in a sequence or on branch based on a decision, or even repeat some part for a finite number of times. Number one. Number one, this is sequence. The name implies what it means. If we look at the examples 4.3 and 4. This one, if we look at the example 4.3 and 4.4, the statements were are executed one after another, right? That is in a sequence. Such algorithms where all the steps are executed one after the another is known as execute to sequence. This is the main purpose. Such algorithms where all the steps are executed one after the other are said to execute in sequence. However, statements in an algorithm may not always execute in a sequence. This is very important line. This is very important point, that statements in an algorithm may not always execute in a sequence. Okay, we may sometimes require the algorithm to either do some routine task in a repeated manner or behave differently depending on the outcomes of previous steps. In this section, we are going to learn how to write algorithms for such situations. Okay, so this is sequence, and then another type is selection. We have to select something. Now, consider the map of a neighborhood as shown in the figure, in the following figure. Let us assume that the pink building with the red roof is the school, the yellow painted house at the far end of the map is a house, and anything. Now, with reference to this one, please you go through all these things. I think this is very easy to understand. There is nothing to explain. So please go through this example. Now, here is an important part. Conditionals are written in the algorithm as follows. How to write down the conditions in an algorithm? The way of writing. If you have to write down the condition, then steps to be taken when the condition is true or fulfilled. There are situations where we also need to take action when the condition is not fulfilled. To represent that, we can write if condition is true, then steps to be taken when the condition is true or fulfilled. Otherwise, steps to be taken when the condition is false or fulfilled. Okay, so this is the main thing. Okay, condition. Condition, what do you mean by condition? Either true or false. If true, then do this. If false, do that or do nothing. Okay, so in programming languages, otherwise is represented using else keyword. Hence, a true or false conditional is written using if else block. Suppose, for example, if you if you get the required pass marks in any exam, then you will be promoted. Otherwise, otherwise you will be not promoted, means if you get the pass mark, then you will be promoted to the next class, otherwise or else part you will not be promoted. Okay, so these are the usage of conditional statement. And then here is an example. Let us write an algorithm to check whether a number is odd or even. We have to check this. So when you have to check any number, so first input, you have to take an input any number, the number which you have to check. Okay, Then process is check whether the number is even or not. This is the process. Check whether the number is even or not. An output message even or odd. Pseudocode of the algorithm can be written as follows. Print, enter the name, input, number. If number mod 2 equals to 0, then print number is even, else print number is odd. This is the pseudocode. Okay, you can see this one. This is the pseudocode. First you have to enter the number, then how to know that this number is even or odd. You have to divide the number with the help of 2. When we divide any number by 2, and if remainder is 0, and it means that the given number is an even number, otherwise this is odd number. And these are the statements which is based on that particular logic, right? Please go through. And here is the flowchart. Start, input num, and this is the decision box. We have already discussed it properly in the previous chapters, previous sections. Okay, previous videos. Please go through. Is num1 mod 2. Mod means modulus operator. This means we have to check the remainder. Okay, it will remainder. If number mod 2 means you have to divide the number with the help of 2, and that equal symbol means the remainder. This operation is used for taking the remainder value. Is if it is equals to 0, then the number is even, otherwise it will be odd. So for any decision box there must be two branches. One is yes, one for no. Is the number mod 2 equals to 0? Yes, then print even, and if it is no, then print odd. And after that you have to stop here. Okay, so flowchart and pseudocode both are given. Please go through. If there is any problem, ask me in the comment section. I will definitely help you to understand the properly. Okay, and here is another example. Let us write a pseudocode and draw a flowchart while multiple conditions are checked to categorize a person as either child this and please go through all those things. Same thing, different, just different in numbers. And algorithm for a card game called Dragons and Wizards. Go through. If any problem I will clear that section. Please go through. Okay. Okay, then okay, repetition. Now the next thing is repetition when giving directions. This is third point, repetition. When given direction to go someplace, we say something like walk 50 steps, then turn right, or walk till the next crossing, then take a right turn. Consider some other examples like clap your hands 5 times. Okay, so repetition of actions. Now, write a pseudocode. There are the kind of statements we use when we want something to be done repeatedly for a given number of times. Likewise, suppose this order example. Now we have to write a pseudocode and draw a flowchart to accept 5 numbers and find their average. Okay, you have to write down this one. So the flowchart representing is here. You can see this here in this section. And now we have to go through the pseudocode. Step 1, set count equals to 0, sum equals to 0. Step 2, while count this one 5, repeat steps 3 to 5. Input a number to num. Step num sum equals to sum plus num. Count equals to count plus 1, and this thing. And then print average. Now look at this section. First one, count equals to 0 and sum equals to 0. While count less than 5, repeat steps 3 to 5. Input, repeat steps 3 to 5. Steps means step number. Okay, step 3, step 4 and step 5 will be repeated here. Input a number to num. One number you have to give an input, give as input. Now sum equals to sum plus num. Count equals to count plus 1. Compute average equals to sum by 5, because we have to take 5 numbers you have to take and then sum it up. And for average you have to divide that particular sum of 5 numbers by 5, and then print average. And now see the flowchart here. Start, count equals to 0, sum equals to 0. Here is another decision box, count less than 5. The answer will be either yes or no, right? So for yes, input num. If the number is less, suppose count less than 5, so count means how many numbers are there. If there are 5 numbers or less than 5 numbers, then only input is taken. Okay, because you have to take the average of 5 numbers, not more than that. And that's why if yes section, then input num, and then sum equals to sum plus num, and count equals to this thing, count plus 1. And if no, then average equals to sum by 5, print average and then stop. Okay, the flowchart to calculate the average of 5 numbers of statements need to be repeated. Such requirements of unknown number of repetitions are handled using while construct. These are the very preliminary concept of program solving technique. The main part will be started in the chapter number 5. And here is another example: write pseudocode and draw a flowchart to accept numbers till the user enters 0 and then find their average value. Another example, please go through same pattern, same thing, same logic is also followed here. If there is any problem, ask me. Okay, and now this is the next thing, verifying algorithms. We have to also verify the algorithm also. Okay, please go through this section. And then comparison of algorithm is also there. There can be more than one approach. This is very important topic about algorithm, we have already discussed it. Again, I will tell here there can be more than one approach to solve a problem using a computer, and hence we have more than one algorithm. Then one may ask, which algorithm should be used, right? If I have more than one option, which option should be taken? This is the main point. Okay, so then we have to compare those options, right? The relevant one should be taken. Here, the consider the problem of finding whether a given number is prime or not. Now, prime numbers are of great importance in computer science as they find application in databases, security, file compression or decompression, modulation or demodulation, etc. There can be 4 different ways to write algorithms to check whether a given number is prime or not, or as shown below. Now, number 1, starting with divisor 2, divide the given number and check if there are any factors. Increase the divisor in each iteration and repeat the previous steps as long as the divisor is less than dividend. If there is a factor, then the given number is not prime. This is one approach. Second approach, in number 1, instead of testing all the numbers till the dividend, only test up to half of the given value dividend, because the divisor cannot be more than half of the dividend, right? And the third approach is, in method 1, only test up to the square root of the dividend numbers. This is another approach. And the fourth one is, given a prior list of prime number till 100, divide the given number by each number in the list. If not divisible by any number, then the number is a prime, else it is not prime. All these 4 methods can check if a given number is prime or not. Now, the question is, which of these methods is better or efficient? Algorithm 1 requires large number of calculations, right? Algorithm 1 requires a large number of algorithms, means more processing time, as it checks for all the numbers as long as the divisor is less than the number, right? So if the given number is large, this method will take more time to give the output. This is the explanation of algorithm number 1. Okay, please study those algorithms first and then go through this section. Next, algorithm 2 is more efficient than 1, as it checks for divisibility till half the number, and thus it reduces the time for computation of the prime number, right? And algorithm 3 is even more efficient. Algorithm 3 is even more efficient as it checks for divisibility till square root of the number, thereby further reducing the time taken. And algorithm 4 uses only the prime number smaller than the given number for divisibility. It further reduces the calculation, but in this method we require to store the list of prime numbers first. Thus it takes additional memory even though it requires lesser calculations. So these are the studies of algorithm. Okay. There are more than one algorithm, four algorithms are here, and we have to study it properly, which should be appropriate for calculation. Now, hence, algorithms can be compared and analyzed on the basis of the amount processing time. Algorithms can be compared and analyzed on the basis of the amount of processing time they need to run and the amount of memory that is needed to execute the algorithm. This is the main funda. These are termed as time complexity and space complexity. This is very, very important term in computer programming languages. Okay, we will discuss it the coming section, but you just know these two terms, time complexity and space complexity. The choice of an algorithm over another is done depending on how efficient they are in terms of processing time required and the memory they utilize, that is space complexity. Okay, this is very important term, and this section is very important. Comparison of algorithms, this is very, very important to you. Please go through it properly, read it more than once, and go through all these things line by line. If there is any problem, ask me. Okay, and then comes the coding section. The ultimate coding section is here. What do you mean by coding? Once an algorithm is finalized, it should be coded in a high level programming language as selected by the programmer. This is the original thing. Till algorithm, this is same for all the programming languages. When the algorithm is chosen, then this is the duty of a programmer to select the programming language, the high level language in which the problem will be solved with the help of that algorithm. Okay, this is known as the coding section. The ordered set of instructions are written in that programming language by following its syntax. Syntax is the set of rules or grammar that governs the formulation of the statements in the language, such as spellings, order of words, punctuation, etc. The machine language or low level language consisting of zeros and ones only is the ideal way to write a computer program. Programs written using binary digits are directly understood by the computer hardware, but they are difficult to deal with and comprehend by humans. This led to the invention of high level languages, which are close to natural high level language. These are close to natural languages and are easier to read, write, and maintain, but are not directly understood by the computer hardware. Okay, an advantage of using high level languages is that they are portable, that is, they can run on different types of computer with little little or no modifications. This is the main thing. And low level programs can run on only one kind of computer and have to be rewritten in order to run on another type of system. A wide variety of high level languages such as Fortran, C, C++, Java, Python, etc. exist. A program written in a high level language is called source code. Now, this is very important definition. What is a source code? A program written in a high level language is called source code. We need to translate that source code into a we need to translate it into a we need to translate the source code into machine language using a compiler or an interpreter so that it can be understood by the computer. We have learned about the compiler and interpreter in chapter number 1. There are multiple programming languages available, and choosing the one suitable for our requirement requires us to consider many factors. It depends on the platform, means operating system where the program will run. We need to decide whether the application would be a desktop application, a mobile application, or a web application. Desktop and mobile applications are generally developed for a particular operating system and for certain hardware, whereas the web applications are accessed in different devices using web browsers and may use resources available over cloud. Now, besides, programs are developed not only to work on a computer, mobile, or these things, all those things, but for what? But it may also be written for embedded systems like digital watch, MP3 player, traffic signals or vehicles, medical equipments, and other smart devices. In such cases, we have to look for other specialized programming tools or sometimes write programs in assembly languages. Okay, assembly languages also. Okay, now the next thing is decomposition. Next thing is decomposition. Sometimes a problem may be complex, that is, its solution is not directly derivable. In such cases, we need to decompose it into simpler parts. Let us look at the railway reservation system we talked about earlier. The complex task of designing a good railway reservation system is seen as designing the different components of the system and then making them work with each other effectively. The basic idea of solving a complex problem by decomposition is to decompose or break down a complex problem into smaller subproblems. Look here, there is a diagram. Trains information, this reservation information, this. Okay, all these things are here. Booking open close list, waiting list, and all those things are here. Information about staff, security, railway infrastructure, then food service, another part, billing service, another part, other details about railways, another part. Breaking down a complex problem into subproblems also means that each subproblem can be examined in detail, right? If there is any very noise in a classroom, we have to the teachers have to arrange the sitting arrangement of the students, right? Breaking the unity, divide and rule policy. Here we also use that one, that formula, right? Okay, let's do it. Okay, so this chapter is completed here. Chapter number 4 is completed here. So in this chapter, a summary part is here. What do we have learned in this chapter? Please look. Chapter number 4, Introduction to Problem Solving. How to solve a given problem. This is the main thing for this chapter. And here we read about analysis of the problem, steps for problem solving. Then, what are the steps? Steps for problem solving are here. Analyzing the problem first, then developing an algorithm. What do you mean by algorithm? Then the coding section, testing and debugging section. After that, after that, here comes algorithm in details. Definition of algorithm, purpose of algorithm, all these things are here. Characteristics of a good algorithm, representation of algorithms. This is important part. Representation, we can represent it either with the help of either flowchart or by pseudocode, right? In today's lesson, we learn about pseudocode and flowchart also, and there are so many examples given in this section. You will please go through all those things. Benefits of pseudocode is also given here. Then flow of control depicts the flow of events as represented in the flowchart. It may be sequential, selection, or conditional part will be here, and all these things are detailed discussed here. And then comes this section, repetition part is also here. Then pseudocode, again and again pseudocode and flowchart are here. After that, how to verify algorithm. This is your home talks. You will go through this section, and then the vital part is here, comparison of algorithm, right? Comparison of algorithm means how to select the particular algorithm. When there is more than one algorithm to solve a given problem, you have to choose the best one, and this is done through comparison. And the main factor is here, it is depending on the factor of time complexity and space complexity. This is very vital, we will discuss it in the upcoming chapters. And then coding, what is coding? And in this section, you will know once an algorithm is finalized, it should be coded in a high level language. And high level language is nothing but plain English language or natural language is high level language. We have to convert it in a machine language with the help of either compiler or interpreter. These all things are there. And then comes decomposition. If any problem is very big and complex, we have to break it down and decompose, and then the smaller sub problems will be studied in a detailed section and it will be solved. Okay, so this chapter is completed here. I think this will be helpful for you. please subscribe my channel, and if there is any query, please ask me. And here is an exercise. Okay, you people please go through all this exercise section and solve it. If you have any problem with any questions, ask me in the comment section. I will definitely help you to solve those problems. Okay, so thank you. Okay, thank you.